All right, example 24. Example 74 says, find the general solution of the equation d2y by dx squared minus 4dy by dx plus 13y is equal to 20e to the x. All right, so we're solving. First, let's find the complementary function, which is the solution of d2y by dx squared minus 4 dy by dx plus 13y is equal to 0. For that, we need the auxiliary quadratic equation, which is m squared minus 4m plus 13 is equal to 0. All right, so we cannot solve this by the method of factorization. So we have to use the quadratic formula, which is m is equal to minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So m, a negative times a negative is a positive, plus or minus the square root of 16 minus 52 all over 2. This is 4 plus or minus the square root of minus 36 over 2. This is 4 plus or minus 6i over 2. This is 2 plus or minus 3i. So therefore, the complementary function would be y is equal to e to the 2x, open bracket, a sine 3x plus b cos 3x, where the 2 and the 3, the 2 is the real part. We have e to the 2x, that 2 is the real part of the solution of the auxiliary quadratic equation. And we have 3 sine x cos 3x. The 3 is the imaginary part of the solution of the auxiliary quadratic equation. So next we want to get the particular integral. Now the particular integral is of the same form as f of x. So y is equal to a e to the x, dy by dx is equal to a e to the x, and d2y by dx squared is equal to a e to the x. So substituting into the equation d2y by dx squared minus 4 dy by dx plus 13y is equal to 20 e to the x, we get a e to the x minus 4a e to the x plus 13 a e to the x is equal to 20 e to the x. So next what we have here is 10 a e to the x is equal to 20 e to the x. And so a would be equal to 20 over 10. A is 2. So y is equal to 2 e to the x is a particular integral, and y is equal to e to the 2x, open bracket, a cos 3x plus b sine b sine 3x plus 2e to the x is our general solution. We were also given information so that we can determine the values of a and b. We were told that when x is 0, y is equal to 0, and dy by dx is equal to 1. So let us substitute both x and y to be 0 to see what we get. So we get 0 is equal to e 2 times 0, open bracket a cos 3 times 0 plus b sine 3 times 0 plus 2e to the 0. All right, so e to the 0 is 1, so this is 1. The cosine of 3 times 0 is also 1. So this is a times 1 plus b times 0, because the sine of 0 is 0, plus 2 times e to the 0, which is 1. So this is 0 is equal to a plus 2. Therefore, a is equal to minus 2. So with that, we now have y is equal to e to the 2x minus 2, the cosine of 3x plus b, the sine of 3x plus 2e to the x. We need to determine the value of b, utilizing that when x is 0, dy by dx is equal to 1. So let's differentiate dy by dx. Product, leave the first, e to the 2x. Differentiate the second. If we differentiate cos, we get minus sine. Minus 3 times 2, this becomes 6 sine 3x, you different sine, you get cos, plus 3b cos 3x. So we leave the first, differentiate the second, plus differentiate the first. When differentiate the first, e to the 2x, you get 2e to the 2x. Leave the second, we have minus 2 cos 3x plus b sine 3x plus the differential of 2e to the x, which is 2e to the x. Now when x is 0, dy by dx is equal to 1. So 1 is equal to e 2 times 0, open bracket, 6 sine 3 times 0 plus 3b cos 3 times 0 plus 2e 2 times 0, open bracket, minus 2 cos 3 times 0 plus b sine 3 times 0 plus 2e to the 0. So this is 1. This is 1 here. The sine of 0 is 0. So it's 6 times 0 plus 3b. The cosine of 0 is 1 plus 2e to the 0, which is 1. So it's 2 times 1, open bracket, minus 2 times 1, close bracket, plus 2 times 1. So this is 1. What we have here, that gone, we have 3b minus 4 plus 2. So here we have 3b is equal to 1 plus 4 minus 2, which is 3. Divide both sides by 3, and we get b is equal to 1. So our particular solution would be y is equal to e to the 2x, open bracket, minus 2 cos 3x plus b, which is 1, sine 3x plus 2 e to the x.